Welcome back. In our last class, we have already solved a few problem sums based on algebraic identities. In today's class also, we will be solving these problem sums. So before that, let's revise the standard identities. So let's start with the first problem sum where we have to simplify this algebraic expression. Now what we can see here that we have in the as the first factor in the first bracket we have 2x minus 1, subtraction of these two terms, and again in the second factor within brackets we have 2x plus 1. We know, we are familiar with this identity a minus b multiplied by a plus b, and that is equal to a square minus b square. Again we can say a plus b multiplied by a minus b, that is also equal to a square minus b square. Whatever, whenever we will be seeing this type of factors where we have like terms and only difference will be in their operation, like we are performing subtraction, here we are performing addition, but both the terms are same. 2x, here also 2x, here it is 1, here it is 1. So it is resembling the identity a minus b multiplied by a plus b, and that will be equal to this format, a square minus b square. So we will be straightforward writing, we will be assuming here 2x as a and 1 as b, and we will be writing this value a square minus b square after using this identity. So directly it will be 2x then whole square of that minus 1 and whole square of that, and rest of the terms we will be writing as they were. 4x square plus 1, here it is 16x to the power 4 and then plus 1. We may not write this line directly if the terms are simple, then we can mentally calculate them and directly we can write. So we can skip this line. Here it will be 4x square and then it will be minus 1, so it will be 4x square plus 1. That way we can save our time. 16x to the power 4 plus 1, and then again we can see here that we have the same the format a minus b, a plus b. Only difference is here a is equal to 4x square and b is again equal to 1. So we will be using this identity a minus b, a multiplied by a plus b. So what it will be? It will be again a square minus b square. So a is our 4x square, then square of that term, and then b is again 1, so square of that term, and this will be writing within bracket. Then we have here, we have already performed between these two terms, so only factor that remains to be written here is 16x to the power 4 then plus 1. So it will be 16x to the power 4 and then minus 1. So directly we can jump to this line, we can skip this line if we are confident enough. Then we have this factor 16x to the power 4 plus 1. Again we have this format a minus b, a plus b. Only difference is in this case our a is 16x to the power 4 and b is again here it is 1. So what we can do, we can use this identity and directly we can write this value a square minus b. So it will be 16x to the power 4 whole square means a square minus b square means 1 square. Now 16 to x to the power whole square means we can separately think this way, 16 square and x to the power 4 and then square of that minus 1. Now 16 square means it will be 256, and here it will be x to the power 4 multiplied by x to the power 4. So since we already have the knowledge of powers and exponents, here the powers will be added. So 4 plus 4 it will be 8. So it will be 256 x to the power 8 minus 1. This will be our final or simplified answer of this algebraic expression. So you have to simplify this expression. Now what we can see here is we have this format a square minus b square. In our case, in this case, a is equal to 2.5 p minus 1.5 q and b is 1.5 p minus 2.5q. So it looks like a square minus b square, this identity, and as per this identity it will be a plus b multiplied by a minus b. Now if we replace our a and b by their original values, 2.5p minus 1.5q, fine, and then minus b. So minus b means here it will be like this, minus 1.5p minus 2.5q. so it will be basically minus 1.5p and minus minus plus 2.5q. so it will be written as minus 1.5p and then plus 2.5q. now we have to simplify our two factors here, 2.5, and we have like term p here and its coefficient is 1.5. so 2.5 plus 1.5, it will be 4p, and then we have two like terms here, we have q. Here their coefficients are minus 1.5 minus 2.5. so 1.5 and 2.5 will be simply added and that will give 4, and minus, both are since negative, it will be minus 4. so it will be minus 4q. so 4p minus 4q, 4 is the common factor, we can take common, and within bracket only the terms that will be left with is p minus q, and here it is p plus q. Again it resembles the identity that we have used initially in this problem itself, and that is p. Here it is the format is a minus b and a plus b. Here it is p minus q and p plus q. so when we will simplify this, so it will be p square minus q square. so finally the simplified answer, final answer will be 4p square minus 4q square. Now our next problem sum says that if 2x plus 3y is equal to 14 and 2x minus 3y is equal to 2, then what is the value of xy? It looks a bit tricky, but here the similarity that these two terms have, here 2x plus 3y and here 2x minus 3y, the terms they are same, only difference is they in between these two terms their sign is different, means we are performing different operation. Here it is addition, here it is subtraction, and their values are given. So if we proceed this way, that 2x plus 3y and that is equal to 14, so if we take the square, if we take square on both the sides of this equation, so it will be 2x plus 3y whole square, and 14 then square of that, it will be 2x then whole square of that, then plus 2ab. so 2a is 2x and b is 3y, and b square is what? 3y, then square of that, and then 14 square, which is 196. so it will be 4x square, then 2 2s are 4, 4 3s are 12. so the next term will be 12xy, and then this will be 3 square means 9, and then y square, and here it will be 196. then we will do the same thing with the second expression or second equation that we have, 2x minus 3y, and that is equal to 2. so here 2x minus 3y and that is equal to 2. so we will again take the square value of both the sides of that equation. so if we further simplify, then it will be 4x square minus 4, and then here it is 3, so finally it will be 12xy, then plus 9y square, and that will be equal to 4. so here in one interesting thing that we can notice here in the patterns of this both the equations, so this if we mark as level as 1 for our first equation, and this if we label as our second equation, we have x square and y square terms in both the equations and their coefficients are same. so here it is 4 and the coefficient of y square is 9, and in the second equation also the coefficient of x square is 4 and the coefficient of y square is 9, and they also have this term xy. In the question it is given only to find the value of xy. so from both the equations, if we suppose subtract the second equation from the first, or maybe the vice versa, what will happen is, since their coefficients are same, so and say their sign are also same, so if we subtract, then this x square and y square term will vanish. Then what we can see here is 4x square, and here we have minus 4x square. The same term, the 4x square itself is positive, but since we are subtracting, so it will be minus 4x square. Then 9y square we have here, 9y square, and the same 9y square we are subtracting, so we can write this way. Then from the first expression we have 12xy, and then from the second expression, algebraic expression, here we have minus 12xy, but since we are subtracting, so finally it will become plus 12xy. And then from the right hand side it is 196 minus 4, so it will be 192. Now what we can see here, that easily this 4x, the x squared term and y squared term we can cancel, because their coefficients are same and here the signs are opposite, so they will vanish from the equation. And here 12xy and 12xy, so their coefficients will be simply added, so it will be 24xy, and from the right hand side it is, what value we are getting is 192. So simply xy will be, or the value of xy will be 192 divided by 24, and if we divide by 8, it will be 8 3s are 24, and it is also 8 2s are 16, and 8 4s are 32. Then 3 8s are 24, so final answer is 8. Now suppose if we wanted to find the value of x square plus y square, means the value in their coefficients may be different, but in that expression, if we have x square and y square, those two terms, and if there is no xy, means if we want that xy vanishes from that expression, then what we will do is we will add them, as we have subtracted after taking the square values. If we have subtracted here, so x square and y square terms vanished from here, and only the xy terms remained. So if we add them, so what will happen, xy term will vanish, because here it will be 12xy and here it will be minus 12xy, we are adding, so this negative term and positive term will vanish, and this x squared term and y squared term will remain in the equation. So in this type of pattern, this type of problem sum, if we have only, we need to find the value of xy, so we will be go for subtraction, we will be subtracting. But if we want to value related to x square and y square term, then we will be adding after taking the square values. Now we will be solving the next problem sum. Here what is given is, we have x plus 1 by x, the reciprocal of the first variable, and that is equal to 12, and we have to find the value of x minus 1 by x, the reciprocal of the first variable. It is simple. What we can do is, we can, in this type of problem where the second variable is the reciprocal of the first variable, then what happens is, suppose if we take this identity a plus b whole square, means x plus 1 by x whole square, then what will happen, it is a square plus 2ab plus b square, right? So if we go by that identity, so it will be x square, then 2a is x and b is reciprocal of the first variable x, so 1 by x, and then plus b square, so 1 by x then whole square of that. So here finally what will be having, x square, then plus 2, and then plus 1 by x square. So one interesting thing that we have noticed here, that the 2ab term, if the second variable is the reciprocal of the first one, then in the middle term, only constant value will remain. So we can rearrange it this way, x square, then 1 by x square, and then plus 2. Now suppose instead of taking a plus b whole square, if suppose we had performed a minus b whole square, then we know this identity is a square minus 2ab plus b square. Again the same variables we will be using, the reciprocal of the first one, the second is. So if we go by this identity minus a whole square, then what will happen, so here it will be x square, and then the third term is same, so that is 1 by x square. Only difference is in the second term, in the middle term, and that is here it is plus 2ab, here it is minus 2ab. And since, as I said, the second term will be only constant term, So the constant value that we have seen here, it is plus 2, so here it will be minus 2. Now if we go by the problem that we were solving, so here it is 1 x plus 1 by x, and that is equal to 12. So if we take the square value, what will happen? So it is x square plus it will be 1 by x square that we have seen, then plus 2ab, a and b will cancel each other, so it will be simply 2, and here it will be 144. So x square plus 1 by x square, that value we can say that is 144 minus 2, that means 142. And what we have to find is here the value of x minus 1 by x, and that value we can find this way, x minus 1 by x. Now if we take the square of that, and directly if we find the square value first, then it will be what, x square again plus 1 by x square that we have seen here, and then minus 2ab, so a and b will cancel each other, so it will be simply minus 2. Now x square plus 1 by x square, this value we have already found, and that is 142. So we'll be writing 142 here, we'll be using that value, and then so it will be 140. Now what we wanted to find is x minus 1 by x, and we have the square value of that. So x minus 1 by x, now if we want to find, then it will be square root of 140. Definitely it will come in fraction, and that will be 11.83. So this is how we solve this type of problem. Now it may happen that x minus 1 by x, that value is given, and we want to find the value of x plus 1 by x. So we will proceed the same way that we have done from this problem, because here we will start from the square value, because x square plus 1 by x square, that value we will be first finding from the first equation, and then that value we will be using in the second equation. So from the second part also we will be first finding the square value, and then we'll take the square root. Now we will solve our next problem sum, which is this. The one expression is given, and x and y, these two values of these two variables are separately given. So we have to find finally the value of this algebraic expression. One way is straightforward, we will be putting the values of x and y in all these terms. That way also we can find the values. Second way is, if we want to save a little bit time, then we can think of that since these terms are square, x square then y square, and here the term is xy. So the first thing that will strike in our mind is whether we can arrange these three terms in the form we can use any identity or not. So here x square with that term is positive, y square that term is also positive, the xy term is negative. So it may strike this identity in first, that a minus b whole square, we know that is a square minus 2ab plus b square, whether we can fit this algebraic equation to this identity or not, because the right hand side resembles this format. So let's do that. Let's try whether we can or not. 81, because 81 we know that is a square value of some other rational number, and that is 9. So we can take this way, 9 square, and we already have x square. So together we can write 9x and then whole square of that value. Then here it is 16y square. 16 we know again this is a perfect square, and that is the square of another natural number which is 4. So it is 4y and then square of that, minus, now we have to see whether we can arrange in this term we can fit in this format or not, 2ab. If we can, then it will simplify our job. So it is 2, and then a value is here 9x, and our v value is 4y. Now we will let's multiply this. 9 2s are 18, 18 4s are, it will be 72. Perfect. So 72 we have achieved here, we have obtained, and xy. That means we can, if this 72 xy can be rewritten or rearranged this way to a and b, where a is 9x, b is 4y. That means we can use this identity and we can write this expression this way. 9x minus 4y then whole square. So simply what we can do is 9, and now here we can put the value of x, which is given as 2 by 3, and here it is 4, and the value of y is 3 by 4, and then whole square of that. So here 3 and here 3, 9 is 3 3s are, so here 3 and multiplied by 2 it will be 6, and here 3 multiplied by 1 it will be 3, and then whole square of that. So it will be 3 square, and then final answer will be 9. So this is what this class was all about. We have already solved 5 problem sums. In the next class we will be learning something new with this in today's class. Thank you.